I have a MacBook Air. So this one, okay, that, wait, okay, okay, yeah, seem to be fine. So it's a no power. It said that it's liquid damage. In an ideal situation, I wouldn't connect power to it, but the reason why I did connect power to it is because I know that the damage is not much compared to what would pose a threat to the board. So I'm just gonna. We kind of have to be quick with this one because the owner is going to be here in about 30 minutes or so. 'Cause say they want it quite urgent. So let's quickly take the back screws out. We are going to use a pentalobe screwdriver to take the back screws out. We have a missing screw there. Mm. So actually the device we had informed we quoted the client, and then the client quoted the company quoted the client, but at first they didn't want to go ahead with the repair, but then they got back to us. Okay, it's fine, you can go ahead with the repair. So um when we had checked, we found that there was liquid on the trackpad cable, as well as the trackpad as well as the trackpad itself. So let's quickly, and if I remember correctly, we were missing pp3v3 underscore source. That was what was missing on the board. Say again. pp3v3 underscore source is a power rail. Okay, so I'm not sure why this is done, but this is reversed. That's not how it's supposed to be. I don't know who did that. So this and that is not, that's not how it should be. This is reverse. It should be the other way. It should be like this, not the other way around. Anyway, so the trackpad and the trackpad cable, you see the trackpad cable, it's damaged on the side, which will mean that also the trackpad itself, but they said it's okay, we can go ahead and fix the board itself. I don't know if you guys can see that. See the liquid. Yeah, so they said that's fine, we can just make sure the board works. And yeah, so with 2011 and above machines, they have the auto start options, which is once the charger, once power it's present from the charger, from the DC in, the device will start. Now this, with this JTech, this is 2015, 2017. We have confirmed already this is a 2015 board, and as you can see, the power is there, but it's not starting. And I can confirm with you that we actually do have power on the board. So we do have power on the board. I'm just going to check here. This is our PP bus fuse. So I'm going to put my black probe on ground and see what we have on our fuse. You see, that is 8.6. 8.6 is good because two things is been confirmed. Number one is PPDC in is present, PP3B42 is present, and SMC is also negotiating with U7000, U7100 in this case, to set a PP bus to 8.6. If that was not the case, you will be getting 8.3 on your PP bus. So this is going to be an E20-00165. We are quickly going to remove the board, and like I said, what we had seen, what was missing before now. Let's quickly open the board view. Before we closed it back, we did confirm that the source rail was missing, and okay, yeah. So pp3v3 underscore source, we did confirm it wasn't. I think also it wasn't completely missing, but it was partially present. I'm just going to confirm if that is still the case. So that we can measure on R8133, and that's going to be this resistor here, this guy here. That is R8133. So let's see if we have voltage on that. That's 0.34. So it's partially present, but it's not. It should be 3.3 volt, but we see we're having 0.34 volts. So let's quickly take the board out and find out why that is the case. And hopefully, by the way, without source being present, the device is not going to start. As you can see, that is why the device is not starting. So let's quickly take the board out and get to understand why source is not present. It's a wrong screw. I keep mentioning to you the length of what goes there. Didn't you find the screw among the screws there, or is that how it came?
That's how it came.
Okay, board is out. Okay, so we have the board view open. Let's go to the schematic. Schematic is going to be 820-00165. There we said 820-00165. There you go. Let's see. 165. Okay, I'm just going to search for it. 820-00165. There you go. I'm looking for the schematic. Let's see how our source rail. So what we are missing now, we've confirmed that the source is missing. So definitely without the source, the board is not going to start. So let us see how our source is going to be created. Now we can use R8133 as our starting point. So let's quickly go to the schematic R8133. So it's R8133. Okay, R8133. And the reason why we want to use that as a starting point is because let's quickly show. So the reason why I want to use that as a starting point is because on pin 1 we have 3.3 volt that is partially present, correct? So we need to see where that is being generated. So we want to use this as a starting point, which is R8133, and then from there we can find out where source is being generated from. So what we're now going to do here, we're now going to copy that pp3v3 source and then paste it on our search to see where that is being generated from, and then find out why it's not being fully generated, because we see it's not 0. Okay, so I'm just going to do this now. So here it says found on 10 pages. Now that is now, so we see here, this is source going into something, not going out of something. We want to see where it's coming out from. Do you understand? So this is not, it's not coming out from U0500. That is our processor. So let's go to next. We want to see where it's being created from. On this page, no, that's not there. Okay, you can pause it. Okay, so we want to see where it's being generated from. So we're looking at a situation where you see how this says out. That's what we're looking for. We're looking for where source is being generated from. So we are going to say next again. Here we see it's present on resistors here, but that's not where it's being created or generated from. We want to see where it's being generated from. Let's move on. Next, here it's going into something. That's not what we want. We want to see where it's coming out from. And on this page, it's still going into something. On this page, you see, it's going into something. It's not coming out. So we want to see where it's coming out from. And here we see it's the same thing is going into something. And by the way, these numbers here, that will tell you, so that will also tell you that you will find source in these pages as well, 8, 11, 14, 46. Okay, let's see. Okay, so this is where we want to be. You see where it says 3.3 source switch. Yeah, this is where it's being generated from. So you see here it says U8020, and then here what we require in order for that to be present is pretty simple. So we have 1 plus 2, and then that's going to be 3. What do I mean? So here it says A2 and B2 is going to be V in, correct? In order for this to be present, in order for our source to be present, NC and NC means is not connected, which means it's not present there. So in order for out, this is a simple circuitry. In order for you to have out, you need to have in and the on switch, correct? So you need to have 3.3 volt if the device is in S5 state. So you need to have 3.3 volt on A2 and B2, correct? And then afterwards, you need to have the enable signal need to be on as well. If these two are present, then you must have 3.3 volt. Now, if these two are present and then you don't have 3.3 volt, now you have two possible issues. It's either the chip itself is faulty or you have a short on the line, correct? Okay, so now let's first identify U8020. So we'll copy that and then we go to our board view to paste to locate U90. U9080 is that U9080? U8020. Okay, fine. So now U8020. So we now want to go to U8020 to see where that guy is. So let's flip the board to the other side. So U8020 is going to be on the other side of the board, and see that and put my machines on. Now U9080 is going to be this guy here. That is going to be our U9080. This guy here. Can you see it?
Yes.
So this is U9080. So what you first thing we want to do, we want to confirm that we don't have a short on that rail. So let's see, do we have a short? So let's see if we have a short on it. Can use the loud guy. Okay, so we can measure for our source here to see if it's shorted. And then yeah, so we have a short on our source rail. That is why the source is not present. So remember how I remember when I said that it's either the chip itself is 40 or you have a short on that line. Okay, so a short on that line, let's see. So the way this is going to work, this is a current sensing resistor, even though it's not present. Pin 1 is going to be equal to pin 2, correct? So the problem now is whatever is shorted, it could either be U8020 or it could be components on the other side of the divide. Do you understand? So it could be on this side here, which is on this side you only have U8020, and what else do you have? Okay, just U8020 is the only component on one side of the divide. Yes, one side of the divide you have U8020. The other side of the divide, you have more components. So you will have, let's see, you have your U6100, that's your SPI ROM chip, as well as that's also known as your BIOS chip. You have a couple of capacitors on the line as well. You have that guy, that's also a cap. You have that guy. So what we are going to do is we are going to look at where the rail itself, the regions that it's present, to see if anything stands out that could suggest. Let's see. So first, let's look at this section here, which is this guy here. Doesn't seem to look. bad. So we might also have to inject the voltage on this one, but first thing first. Okay. And we also hope that because some of those lines go to the PCH, and this which is on the CPU. So we also hope that this is not a case of a failed. Just to confirm that the CPU itself, we don't have a problem on it. Okay, it doesn't seem like we do, because usually if you have an issue around the PCH, you get like a physical pop around here. Okay, so that doesn't seem to be the case, even though we see this that's not looking good, but that's not on the source line. That is also not looking good, but that is not on the source line. So we hmm. Okay, first let's remove the regulator itself, even though uh, let's see. So let's remove U 8020. Say again. It's yeah, that's okay. Uh, let's see. Okay, it's out. Let's see if that's where our short is coming from. No, it's not. Our short is still there. So to make the process easy and to make the process quick, we are going to inject voltage on that line. Let's put back U8020. So the idea, it's whatever on the board that is getting that voltage is going through to ground will become warm. And now because of some of the lines going to the CPU, which is the PCH being same, we'll have to be careful. And just before that, let's just see what we have on see what we have on the CPU line. Okay, so that's not supposed to. It's not supposed to do that. Is our diode low? 0.72. Okay, but it seems to be increasing though. So we are we're measuring now. It's I mean 1 volt, 1 point something volt inductor. So that's 1.5 volt inductor. Let's see. 0073. I think that's a bit low. Let me get another board. Red probe and then black probe. Yeah, 0185, but here we are getting 0077. That's quite low. So what we want to do, just to confirm that our problem is not on the side, we're going to remove that inductor. So if our problem happen to be on the side of the CPU, then we are not going to worry with the board. We have to inform the client that okay, this is because a faulty CPU is just going to make the repair more expensive than we had originally charged. So if we have to continue, we have to inform the client. Okay. The reason why we had to remove the inductor, it's that you see that, oh yeah, this is not even connected. So the inductor, it's like a wire. And the inductor, it's also it's a coil as well. So a wire, the one end is going to be equal to the other end. So by removing the inductor, we have effectively separated. We've created remove the bridge between. So now we want to say if the short is on this side or the short is on that side. So if we see pin 2 of it, it's going to make its way to the CPU, PCH. This section of it is the CPU here. So you see this, here, PCH and the CPU. Now, here we are going to be looking at the PCH, and then the other side here we are going to be looking at, this is where it's being generated from. So let's see what we have on both sides, and that will give us an idea where the short is coming from. So red on ground, 0071, yeah, it's coming from the side of the CPU. So this is going to be, and then also that also suggests why we have, yeah, so this is going to be a waste of time. So this is not going to be worth it. We are just going to tell the, okay, so we let the client decide. If they want to fix it, it's just going to be a little more just a little more expensive than the initial charge. And yeah, if they want to, and then we can, yeah. But the short is on the side, which is the side of the CPU. So we are going to reach out to the client, and then we can take it off from there. Thank you guys. I will see you guys later.